Now we're going to take a look at how to express imaginary numbers in standard form. In the last part of the last video, we saw a plus bi. This is what's called standard form of a complex number. It's got a real part and an imaginary part. A is the real part. B is the imaginary part. So for part A, if we're simplifying this to a complex number in standard form, we can't have that square root of negative. So we're going to simplify that piece, and we get the square root of 9 is 3, square root of negative 1 is I. Next example, we've got I squared, so we have to simplify that power. If you remember, I squared is negative 1, so we get negative 6I minus 3, which is the 3 times negative 1, but standard form is the real part first, so we're just going to flip it around, negative 3 minus 6I. Next, we're just going to combine like terms. The I works the same way that a variable works, so we can just ignore the fact that it's the square root of negative 1 and simplify our expression. Distributing the negative 4 and combining like terms, make sure you keep your real part first and your imaginary part second for it to be in standard form. Multiplying, same thing. Foil your binomials just like you would foil a binomial with a regular variable. So we get 4 times 2, 4 times negative 3i, 5i times 2, and 5i times negative 3i gives us that negative 15i squared. So I'm going to combine my negative 12i and my 10i at the same time that I simplify my negative 15i squared. I squared is negative 1 times negative 15 makes that positive, adding that to the real part and making sure you get it in standard form. The next one is an example of conjugates. So let's see what happens when we multiply imaginary conjugates. 1 times 1 gives us 1. 1 times 8i, negative 8i times 1, and negative 8i times positive 8i gives us negative 64i squared. Simplifying the same way I did on part B, my imaginary parts cancel. I get 1 plus 64 when I simplify that I squared, which gives me 65. Now, this is a real number, but it's also standard form of a complex number. B is just 0. The last one, what we have to do on this one is kind of rationalize the denominator, similar to the way that we rationalize a denominator when it has a radical in it. If the denominator is a binomial, we multiply by the conjugate. Why? Well, as we saw in example E, when you multiply conjugates, you end up with a real number. There's no more imaginary parts. So I'm going to start by multiplying by 3 plus 4i. In the numerator, I need to distribute, so I'm going to multiply or FOIL those out. And in the denominator, because I know what happens when I multiply conjugates, I can skip to multiply the first times the first, 3 times 3, and negative 4i times positive 4i. Because those middle parts will just cancel, they'll be opposites. Simplifying in my numerator, I get 9 plus 18i minus 8 after I simplify that I squared to negative 1. In the denominator, I get 9 plus 16 after I simplify by negative 16i squared to times negative 1. So in the numerator, 9 minus 8 gives me 1. And in the denominator, 9 plus 16 gives me 25. This is not standard form. I need to do the butterfly method. Maybe some of you remember that when you divide into both terms in the numerator and split it up. So we get 1/25 plus 18/25 I. And of course, if either of those fractions simplified, you would do so as well.